Good evening, everybody, and I want to continue with the moon. We looked at the phases of the moon. That was one result that we get from the moon revolving around Earth, and we're going to take a look at the second and third effects. So the second effect are the tides that we see on Earth. Those are caused by the gravitational attraction between the Earth, the moon, and the sun, all three of them, but it's mostly the moon because the moon is so close to us. The other thing about tides, I know we talked about it in class, is that we can predict them. We know the exact time that we get our tides every day, both high and low tides, and we would say they are cyclic and predictable. So those are two important things to know. Another important fact about tides, there are two high tides every day and two low tides. So since we have four different types of tides and 24 hours, we usually spread out the tides roughly 6 hours apart. So let's just say we had a high tide at 6 a.m. We would have a low tide around noon, then another high tide at 6 p.m. and another low tide around midnight. So each low tide is separated 12 hours apart, and each high tide also 12 hours apart. And just taking a look, let's take a look at what causes the tides. So if you take a look here, here's Earth. You got to look right there, that little circle in the middle. And this is just an exaggeration. These are 4 different points. They're supposed to represent somewhere on Earth. So here's the moon, here's Earth, and this location right here is going to have a high tide. Any location that's lined up with the moon, perfect line, would be a high tide. So location 4 and location 2 would have high tides since they're right in line with the moon. The moon's gravitational attraction will pull the water up from the Earth's surface, and that's what causes the high tide. For a low tide, look at point 1 and point 3. You would have any point on Earth that is a right angle from the moon would have a low tide. That's because the water is getting pulled out here and getting pulled down toward the center of the Earth when you are at a right angle from the moon. So again, location 1, location 3, those would be low tides. Location 2 and 4 are high tides. That's the simple rule for that. Now, one other thing they sometimes ask about are what we call spring tides and neap tides. Just taking a look at spring tides and neap tides. This is usually the more important one that they ask about, spring tides. Spring tides are the highest possible tide you can get on Earth, and also the lowest possible tide. So you'll see like a very, very high tide during a spring tide and a very, very low tide during the spring tides as well. And here's what causes them. I'm just going to kind of focus in on the picture here. And this is your classic spring tide right there. So take a look. Here's the sun, right? And you know in that picture they always put like the sun's rays. Here's the moon, and here's Earth. Now, if you're at location 4, you not only have the moon pulling at location 4, but you also have the sun's gravitational pull. So that's going to cause the tides to go really, really high here. And also at location 2, remember, anywhere in line with the moon and the sun, you're getting a very, very high tide. So these are called spring tides. And if the water is getting pulled up a lot here, it's getting pulled down quite a bit here. Very low tide. So spring tides, again, you're looking for the sun, the moon, and the Earth to be in line. That's how you get your spring tides. Neap tides are basically, they're not, the high tides don't go as high as normal. The low tides don't go as low as normal. So what happens there is you don't really see a big difference between the high tide and the low tide. Can't really tell too much. And here's the rule for a neap tide where you can't tell too much. You have the sun, the Earth, and the moon, and you could see that would be a right angle between the sun, the Earth, and the moon for really not too many differences between the high tide and the low tide. All right, let's take a look at the third thing that the moon causes, and that's eclipses. And basically an eclipse is when one object in space becomes partially or completely blocked or goes into the shadow of another object in outer space. So we have two types of eclipses here. Solar eclipses. We name our eclipses for what is actually getting blocked when we're looking from Earth. So Sol, you could think of the sun. The sun is getting blocked. And there's only one way for that to happen. Take a look at this picture right here. I'll go down, zoom on that a little bit right there. And here is how you get your solar eclipse. Here's Earth. Someone standing on Earth. Here's the sun. In order for the sun to get blocked, there's only one way that's going to happen, and that would be for the moon to actually get in the way. This does not happen every month. Eclipses don't happen. I think I said it before. I'll say it again. This is on a piece of paper. Everything's flat. They're lying right lined up perfectly with each other. But normally what happens, the moon might be a little bit up here, and we would say that's at a 5-degree incline tilted from the orbit. So it's not in a perfect plane. All right. One of the things they want to know also for a solar eclipse is what phase of the moon. There's only one phase where we can actually see a solar eclipse, and that would be, let me just get my phases of the moon diagram. That would have to be right. Let's see if I have a better picture. Alright, I don't, but this kind of shows you could actually see the sun either way. But look, here's the sun, here's the Earth, and here's the moon. So if the sun is here, here's the Earth, you're standing here, the moon blocks the sun's rays. Again, to tell what actual phase we're looking at, remember we can't see the half of the moon that's on the outer part of the circle. I'll cover it. And if you're looking from Earth, that is the new moon. So the only time that we get a solar eclipse where the sun is getting blocked by the moon is during the new moon phase. Now the other type of eclipse would be a lunar eclipse. That's where somehow the sun's rays are getting blocked from shining on the moon. And again, we're working with the sun, the Earth, and the moon. Here's your lunar eclipse, and you can see the positioning here, the sun, the Earth, and the moon. And what's going to happen again, once the Earth kind of lines up, goes from that 5-degree tilt off the orbit, it will actually block the sun's rays from hitting the moon, and that would be a lunar eclipse. The Earth would cast its shadow on the moon, and if they ask you what phase that is, here's what I like to do actually. If they ask you what phase it could happen, just kind of draw it out. A lunar eclipse means you have the sun here, right? Then you have the moon getting blocked, and it has to be Earth blocking the sunlight from hitting the moon. Now, if they ask you what phase, here's what I do. I just kind of draw this picture, kind of split the moon in half, and here's the sun. It's lighting up this half of the moon, so this half has to be dark. And then I say to myself, well, we can't see this half of the moon, so what does it look like to us? It looks completely lit up. So for a lunar eclipse to happen, this should just make sense anyhow. For a lunar eclipse to happen, that means you have a full moon and it slowly starts to disappear. So the lunar eclipse happens during a full moon, and the solar eclipse can only happen during a new moon. Hopefully that clears up eclipses and also clears up tides. If there's anything else I need to cover, I will make sure to cover it. You guys have questions on this, so look over your PowerPoint. If you need to look over this video again, another exciting 10 minutes. All right, hang in there, everybody. Have a good day.